We've talked about acids, we've talked about bases. Back in chapter 4, when we talked about neutralization reactions, we talked about when we react an acid with a base, we produce a salt and water. We're going to modify that a little bit. We've talked earlier when we were talking about Bronsted-Lowry reactions, when I have an acid and a base reacting, sometimes they don't produce a salt and water. Sometimes they produce a conjugate acid and a conjugate base. And in other cases, we produce a salt and water. Definition of a salt is the anion of the acid and the cation of the base. Strong acid plus a strong base, I get a neutral salt. I can also have acidic salts or basic salts. We'll start by looking at acidic salts. Acidic salts, when they're dissolved in water, produce hydrogen ions. Acidic salts tend to be the anion of a strong acid and the cation of a weak base. So if we take a look at the example here, ammonium chloride. Ammonium chloride is a solid, it's a white solid. When I dissolve it in water, I get ammonium ions and chloride ions. The chloride ions don't react with water. The ammonium ions, however, because they are from a weak base, are going to react with water. So I have an ammonium ion combining with water, and what happens is the hydrogen ion trades species. The ammonium ion gives it up to give us ammonia molecule, and I get a hydrogen ion. The Ka for this reaction is actually Kw over Kb, because this reaction is very similar to my dissociation of ammonia. I have ammonia plus water to produce ammonium ions plus hydroxide. It turns out that the Ka is equal to Kw divided by Kb. So to get the Ka, I'm going to take 1.0 times 10 to the negative 14 divided by the Kb of ammonia, which we saw is 1.8 times 10 to the negative 5. And when I do that, I get this Ka for the reaction of the ammonium ion with water to produce hydronium ions. Basic salts are salts that when I dissolve them in water are going to liberate a hydroxide ion. Basic salts come from a strong base plus a weak acid. So the example that we're looking at here is sodium acetate. Sodium comes from sodium hydroxide, the acetate ion comes from acetic acid. When that solid dissolves, I get sodium ions and acetate ions in my solution. Sodium ions, because they're from a strong base, do nothing. They just hang out in water. The acetate ion, however, because it comes from the weak acetic acid, which is, being a weak acid, not wanting to dissociate, that negative ion is going to grab the hydrogen off of water. So here's my acetate ion. Here's the water in the solution. It will pull the hydrogen off of the water to form the acetic acid, which is its much more comfortable state, if you want to look at it that way. And what's left behind then for the water is just the hydroxide ion. Because I'm forming a basic solution, I have a Kb for this reaction. And just as before, the Kb in this case is equal to Kw divided by the Ka of acetic acid. So I can go from acid and base K values to their salt equilibriums, as long as I remember that I'm dividing the Kw by either the Ka or the Kb. Now, we have strong acid plus weak base, strong base plus weak acid. What happens if I have a weak acid plus a weak base? Here's an example, ammonium cyanide. Ammonium ion comes from ammonia. Cyanide ion comes from hydrogen cyanide. When the salt dissolves, I have two ions, both of which are going to react with water. So if we want to make this more complete, we'll add our water molecule here, and we're going to get hydronium ion. Ka is Kw over the Kb for ammonia. So we get a Ka of 5.56 times 10 to the negative 10. Cyanide ions are going to react with water. They're going to pull the hydrogen ion off the water to form hydrogen cyanide and leave the hydroxide behind. So we need to find the Kb. So we take Kw divided by the Ka for hydrogen cyanide, and we get a Kb of 1.6 times 10 to the negative 5. So how do I tell if it's an acidic salt or a basic salt or neutral? If the Ka is bigger than Kb, that means I'm going to have more hydrogen ions present than hydroxide ions. That means the pH is less than 7, so it's acidic. If the Kb is greater than Ka, that means I have more hydroxide ions present than hydrogen ions. The pH is going to be greater than 7, and I have a basic salt. Sometimes, just for kicks, Kb equals Ka. Then, hopefully, you've been able to draw the conclusion that pH is going to equal, hopefully you guessed 7, or you deduced 7, so I have a neutral salt. When I have salts of weak acids plus weak bases, I can't just look at the compound and deduce, unless I've got a whole bunch of Kas and Kbs memorized, whether it's going to be acidic or basic or neutral. So then you have to do the math. So based on this, if we look at our Ka and Kb for ammonium cyanide, Kb is larger, so ammonium cyanide is a basic salt.